Hello everyone. In this video tutorial, we'll learn about the programming languages. What are the different kind of programming languages available today, and basically we'll learn about the compilers and interpreters. And now we'll start about how a program works. In the hardware section in our earlier video, we have seen that the computer consists of one thing that is called the CPU, right? And then so this is the CPU thing that we have learned in the hardware part. So basically it is the nerve system of the computer, and whenever computer does something, the CPU is the most essential part which does all the operations. So what are the kind of operations that a CPU can do is kind of it can read a piece of data from main memory, it can add, it can subtract, it can multiply, it can divide, or it can moving a piece of data from one memory location to another, which is nothing but copy functionality, and compare one value with other value. So these are the things that CPU does, and whenever the CPU does this kind of things, the computer actually performs the operation. So as you can see here, that as you know that computer only understand the binary language, which is called the machine level language, and binary language is nothing but your in this format. So this might be when this particular thing like 10110000, it might be an instruction to the compiler, to the CPU of the program, to the CPU of the computer. So computer treat this as an instruction, but as a human being, I really don't know what this instruction is. So as you can understand, it is very difficult for us to write our program in zeros and ones. That is why the concept of high level language and assembly level language comes into picture. So assembly language program is nothing, it's an intermediate language which is actually not a high level language and not a machine level language also. So the kind of example of assembly level language is something like this. You are moving the value of x to y, and then adding x with 2, and then again moving the value of y to x. And there is a piece called assembler, which is again a software which takes this assembly language and translate it into machine language, which is nothing but your zeros and ones and binary data. Now coming into the high level languages, the people also feel that writing the code into assembly level language is not so easy. So we need some language which human will be able to understand very easily. That's why the concept of high level languages come. It's in mid of 1950s. People wrote something on high level language programming. So in high level language program, we can write something like this: z is equal to x plus y. So we know that what we are doing here is x, whatever the value of x is and whatever the value of y is, we are adding them, and then we are putting the summation value to z. Similarly print this thing, simulation. So here what we are printing is we are printing this text. We can understand the human, as a human we can understand what we are trying to do. That is why this is called a high level language. Again, as I told you, high level languages are understood by human beings, but computer only understands zeros and ones, which is the machine level language. So that is why the necessity of compilers or interpreters come into picture. So I'll just define or discuss about the compilers and interpreters little bit here, how these things works. For an example, you as an English speaking person, you want to communicate with a person who is a French guy. So let's assume that you do not know French and the French guy doesn't know English. So how will you communicate? Of course, the answer is you need a translator, right? So somebody will translate what you are speaking in English to French to him, and when he will reply or he will have some, when he will try to communicate with you, the French guy will try to communicate to you, the interpreter or the translator, he will translate the French to English. So that is how the translation, the human level interaction works. Similarly, here also the compiler does the job. The compiler does the same job. So whenever you have a source code or which is written in high level language, it gets into the compiler and the compiler translates that into the machine code. So this is the basic nature of the compiler, that whatever the program that you are writing, for example, you are writing a C program or a C++ or Java program. So each and every programming language has its own compiler. Okay. So once you finish your writing the code, you will submit that particular things to your compiler, and then compiler will take it to convert it to the machine code. That is how the things work. So as you can see here, like your example here, the example is like we are having high level language, we are assigning the value 10 to x, we are assigning the value 20 to y, we are doing the sum operation here, z is equal to x plus y, and then we are printing the value z, which will be 30. So as you can see, once we put this code through the compiler, it translates into machine level language. And this machine level language is are nothing but the instructions. This instruction means, you are actually assigning a value 10 to x. This instruction means you are assigning a value 20 to y. And this instruction means you are summing up, adding up the value, and then assigning the value to z. So similar to compiler, there is one more thing is called interpreter. Some programming language use the interpreter instead of compiler. So it does the same thing, but there is some basic difference. So let's take a look at the basic differences that they have. So one thing that you will notice about it is the interpreter translates programs one statement at a time, but compiler scans the entire program and translate it as a whole into machine code. So interpreter does it one by one, but compiler does it as a whole. So interpreter, in this particular point, it takes less amount of time to analyze the source code, but the overall execution time is slower. As you can understand, because it is taking the statements one by one. So for a particular statement to analyze, it takes less amount of time, but overall execution is higher. But on the contrary, compiler, it takes large amount of time to analyze the source code because it is actually evaluating your source code as a whole, but overall execution time is comparatively faster because when you run the code, when you execute the code, at that time all the analysis have been done. So analysis takes time, but your execution time is faster in case of compiler. So now we are coming to the third point, which is no intermediate object code is generated, hence are memory efficient. It generates some intermediate code which further requires linking, hence requires more memory. As you can understand this is self-explanatory. Then interpreter in the next point is continue translating the program until the first error is made. But here the compiler, it generates the error message only after scanning the whole program. So as you know, the basic difference is the first one that we have discussed over here, right? So the interpreter, it takes one statement by one and then it goes executing. But compiler, it takes the whole program, it analyzes it, it finds out some error, and if it goes fine, there is no error, then only it translates into some other intermediary object. So that is the explanation of this particular point is doing. Now the fifth is the programming language like PHP, Python, Ruby uses interpreters, but the programming languages like C, C++ use compilers. So that is how the the compilers and interpreters has a basic difference, but only thing that you should understand is a compiler or an interpreter is required to translate your code to machine code, basically machine level language which computer understands, which is nothing but your binary numbers, zeros and ones. Okay, stay tuned for the next video tutorial where we'll be jumping into the C programming code, and then we'll be going through various examples of writing simple programs like hello world to swapping the programs, writing a program to calculate simple interest, translating one temperature from another kind of temperature like Celsius to Fahrenheit. All those examples will be coming into the next video tutorials. Stay tuned. Thank you.